Hello and welcome. In this video, we are going to show you some results of a hands-on competitive analysis study of Oracle ZFS storage system against Netapp system conducted by Strategic Focus, a strategy consulting and market research firm based in Silicon Valley, California. The study was conducted under contract from Oracle Corporation. In this video, we will compare Netapp on-command balance against the Oracle ZFS storage in identifying and isolating a storage performance issue in a virtual environment. In this video, we will show that 1. Unlike Netapp, Oracle ZFS provides for real-time analytics of virtual machine disk performance. 2. Oracle ZFS provides for granular review of data storage analytics by the administrator, a capability currently not provided by Netapp's on-command balance. 3. Troubleshooting virtual machine performance issues directly from the array GUI is possible with Oracle ZFS, unlike Netapp's on-command performance software that requires a separate GUI. 4. Oracle ZFS requires no additional deployments for virtual machine analytics, whereas Netapp's on-command balance software requires a dedicated VM appliance and a separate host proxy. Here is the default on-command dashboard. Let's review the high-level status of the virtual machines. We can see the number of virtual machines monitored, arrays, and overall health of the environment. Let's look at the servers and the current server's health. The VM PI is the performance index of the VM, and we are going to base most of our analytics on this metric. We're going to generate workload using I/O meter, using a fairly standard workload of 4K blocks and a 50-50 read versus write I/O mixture. As you can see, when we launch this, we will generate a substantial workload and see the difference between VM 112 and other guest on the host. As the workload is generated, we should see specific VM differentiate itself with an on-command. Let's go back to the dashboard and look for any alerts or any analytics based off the I/O meter workload that was just kicked off. We do not see any changes compared to the original VM PI that we noted. We can look at the server workload now and see if the PI has changed yet. Everything seems to be the same as it was earlier. Let's wait for this to update. After over 46 minutes, we now see the VM 112 PI has gone up to 41. We can begin to dig into this VM and understand the workload characteristics. The summary page provides the overall information about the virtual machine. We can see the CPU and memory utilization here at a high level, but storage analytics is our key focus. So let's look at the storage tab. As the storage tab launches, we see disk groups, LUNs, and volumes. We're going to focus on LUNs because there are individual disks allocated to this. We can open the LUNs tab and drill into a single day's worth of data while looking at the raw data. This will help us to understand the performance characteristics as we scroll through the page. We can see I/O, response time, throughput, and also an increase in I/O for this particular VM. Data is presented in 15-minute increments. We will dig into the first disk that shows us the most workload, again tracking just 1 day worth of raw data analytics. We will scroll down here to view the outstanding I/O and throughput. In throughput, you can also see read I/O and write I/O, which is 50-50, which is reflective of the I/O meter workload generated earlier. We also see an alert was generated as well. Let's open and see what on-command is telling us. We can see that we have a hotspot and some basic information as to what happened. Now let's look at Oracle ZFS platform. Here we are logging directly into the storage array interface. We will begin to look at the analytics overview. We dig into the status screen where we see the analytics we are interested in. Now let's review the NFS workload. Here you see a standard workload being generated by a number of VMs. We will dig into this a little bit further. Each VM disk has an independent file name, so we will get the file names on this NFS mount point to see which ones are generating workload based on their NFS operations per second. Here we can see each VM's file name. We will expand this so we can understand what VMs are doing what workload. Please note that the VMs are generating consistent workload. Let's launch the I/O meter like we did during Netapp on-command balance part of this demonstration. Again, using fairly standard workload of 4K blocks, 50/50 read versus write I/O. The key differentiator with Oracle ZFS as compared to Netapp on-command balance is the analytics are shown in real time. You can watch the load change as soon as the I/O meter is started. Now the operations per second have significantly increased, and we can also see the file names of a specific VM is generating much higher workloads than the other ones. As highlighted, it becomes immediately clear which VM is the culprit. Now we can drill down further to get more information. Here you see a mixture of read and write I/Os, which is 50/50. Let's drill down to see the size the I/Os are running at. It should match up with what the I/O meter workload was, 4K block sizes. Here you can see every I/O being generated is close to 4K. The ZFS platform provides flexibility by allowing synchronization of each of these data points to ensure readability, even as new data points are added or timeframes changed. For example, we are increasing the amount of data we are looking at by expanding the timeframes on these, and the data is being synchronized, and you can see they are moving in parallel to one another. Now we will stop the workload and see how Oracle ZFS responds to the decrease in the I/O. Again, we can see almost immediately that the I/O or the operations per second on the NFS share has gone down drastically. To summarize, using Oracle ZFS, we are able to quickly identify which VM was causing the highest workload against a given NFS data store. Here are the key differentiators we want to call out between Oracle ZFS and Netapp FAS storage solutions.